Hello and welcome everyone. In this video we will see it looks so complicated. What is the point of trigonometry and calculus? This video is brought to you by Question Response. Thanks to Joshua Engel, Bill Weldon, Andrew McGregor and Anon Baumek for their answers to this question. We'll start with Joshua Engel's first answer.
Calculus is extremely important in sciences. It's the answer to the old question of how you can add up an infinite number of infinitely small things and get a finite answer. Lots of stuff in science does that. It's how you can figure out how objects move when gravity is pulling them in a slightly different direction at each instant. It's how you can describe the behavior of immense numbers of objects, like atoms, or even people, by treating them as if they were infinite. There is pretty much no science that does not involve learning calculus. It's also the basis of statistics, summing up the probabilities of large numbers of things, which requires calculus to fully understand. Trigonometry is a bit harder to justify, especially as it's taught now. At one time it was fundamental to manipulating observations using angles, anything from building to navigating. Computer graphics are all about trigonometry. It's still required to do those things, but it can seem kind of abstruse without that context. Also, trigonometry is used all over the place in calculus. Sometimes, calculus is used to add up infinite number of sine waves. That's the basis of how music is transmitted on the internet. And there's a deep relationship between trigonometry and exponentials, and a lot of things in the world are continuously exponential. Even your money, when you deposit it in a bank. And weirdly, there are some things in calculus that don't involve trigonometry which actually work best by treating them as trigonometry, and then converting them back at the end. If I were designing the curriculum from scratch, I would incorporate trigonometry into other fields, rather than teaching it as its own separate, somewhat confusing class. In the end, there is a lot to know, a lot of fundamental formulas which might seem more meaningful if you knew how they were applied via calculus and linear algebra. My main complaint is that trigonometry is, if not completely useless without calculus, unlikely to get a lot of application if you're not headed there. The best we can say is, all math is good for teaching people to think rigorously, which is true, but I wouldn't use trigonometry for that when there are so many other kinds of math. Still, we're not going to fix that in a Quora answer. If you're taking trig and calc, you're probably on some kind of STEM track, and trust me that you will absolutely use both of those all the time in STEM classes. Maybe not all of the parts they teach, like I said, I don't love the way they design the curriculum. So do pay attention, because it's going to be important.
The following answer is from Bill Weldon.
I build computer games for a living, and I use trigonometry all the time. Even calculus at times. It allows you to deal with things that you have to measure, but which are constantly changing. You're at an age where your brain can be trained to understand these things intuitively. That will be pretty much over by the time you're 24. Don't waste the time you have. Oh, and pick up a second language while you still have time. If you do that, the third and fourth languages will come much more easily.
We continue with Andrew McGregor's answer.
Trigonometry is a building block for calculus. The main use for it on its own is surveying land so people know how owns what, and so large structures can be built. Calculus is how you calculate the way things will move, so it's necessary for many kinds of science and engineering. Also finance, actually. It's the answer to how you predict the speed and location of things that have their speed changing under external forces. There is another field of mathematics, linear algebra, that ends up being more important than either because you can do both calculus and trigonometry with linear algebra, and doing so is easier with computers. However, to learn linear algebra, you need to know some trigonometry and calculus first. Any job that actually uses any of these is going to be well paid. The answers you get tend to matter.
The following answer is from Anon Baumek.
A2A. I would say yes, because I learned trigonometry first, before moving on to explore calculus on my own. Here's how I learned. In fact, I was in the 8th grade when I first came across this. dx, x, dx, opening parenthesis, x, 2, closing parenthesis, dx, opening parenthesis, x, 3, closing parenthesis, dx, opening parenthesis, x, n, closing parenthesis, equals 1, equals 2x, equals 3, x, 2, equals, ddx, x, equals 1 ddx, x2, equals 2x ddx, x3, equals 3 by 2 ddx, xn, equals. Yes, the book that I learned from didn't give me the formula directly. It wanted me to drag out a pattern from the results that it gave me, and I did. After that I learned the basic properties of derivatives. dx, f, x, plus or minus g, x, dx, kf, x, dx, constant, dx, f, x, g, x, dx, opening square bracket, f, x, g, x, closing square bracket, equals, dx, f, x, plus or minus, dx, g, x, equals k, dx, f, x, equals o, equals f, x, dx, g, x, plus g, x, dx, f, x, equals, g, x, dx, f, x, minus f, x, dx, g, x, closing square bracket, 2, d dx, f, x, plus or minus g, x, equals d dx, f, x, plus or minus d dx, g, x, d dx, kf, x, equals k d dx, f, x, d dx, constant, equals 0 d dx, f, x, g, x, equals f, x, d dx, g, x, plus g, x, d dx, f, x, d dx, f, x, g, x, equals g, x, d dx, f, x, minus f, x, d dx, g, x, g, x, 2. I did not even mention the chain rule here. That took me a while to get, and I like how I can deliver the concept of chain rule to others today. But this post is not about me. Let's carry on. Don't worry about these formulas for now. If you sit with a calculus book, you should be able to get them in an hour or so, except for the chain rule, that takes a little longer. For the ones who are well aware of these, you notice how cranky those formulas are. They didn't use the shorthand prime for the differential operator. Heck, I didn't even understand what a differential operator meant. I just found a pattern and tried to follow along with it. It took me a month till I realized that I was calculating something similar to slopes. I still didn't have a clear concept until I went to the university. You see, I'm much dumber than the average human being. But so far, I was only playing with algebraic polynomials. Guess how I panicked when I came across these? d, dx, sinks, d, dx, cos x, d, dx, tanks, d, dx, cscx, d, dx, sec, d, dx, cotex, equals cos x, equals minus sinks, equals, sec, 2, x, equals minus cscx cotx, equals sextanks, equals minus, csc, 2, x, d dx, sin x, equals cos x d dx, cos x, equals minus sin x d dx, tan x, equals sec 2x d dx, cscx, equals minus cscx cotx d dx, sec x, equals sec x tan x d dx, cot x, equals minus csc 2x. Holy moly, I know only the first two, they involve sine and cosine. No, I meant that I barely memorized them. I know tangent, but how the heck does it go to secant squared? I was doomed. Now, I did learn about sine, cosine and tangent and how they are connected to each other in the right triangle ahead of stumbling across Mr. Newton's calculus and derivatives. But how the heck is that going to help me figure out how to take a derivative? Yes, I didn't use the unit circle to learn trig functions. I memorized the entire table of basic angle and their values. I learned, barely touched, quadrant system in the 9th grade. So it was back to square one for me. If you don't know the fundamental definition of derivative, which I learned much later, then you won't have much choice other than memorizing the information in front of you. And as always, you have to come up with your own pattern so it stays in your head. That should barely sum up differential calculus. Touching integral calculus without prior knowledge of trigonometric functions, and I mean proficient knowledge to be precise, is suicide.
The video is over. Thank you for staying until the end. If this answer helps you, please help us too by leaving a like and subscribing to this channel. It allows us to move forward on YouTube. We are coming to the end of this video. Share your views on this question in the comments. See you next time.